1. This is for pre-calculus. It's on rationalizing the denominator. The idea is you want the radical in the bottom to go away. That it's an etiquette thing. It's not necessarily that it's mathematically wrong. It's like chewing with your mouth open at the dinner table. It's just something you're not supposed to do. So if this was something over the square root of 3 squared, then the square root would go away. So I don't undo this by squaring the top of the bottom. I get rid of it by multiplying the top of the bottom by the square root of 3. In other words, I multiplied it by something that's worth 1. 1 over the square root of 3 times 1 is still 1 over the square root of 3, so I haven't changed its value. This is worth 1. So the top is square root of 3. The bottom, slowing it up, is the square root of 3 squared. Square root of 3 times square root of 3 is square root of 3 squared. So the top stays the square root of 3, but the bottom is now 3. Square root of 10, I'm going to multiply by the square root of 10. So you get 5 square roots of 10 over square root of 10 squared. I'll skip this step as we get a little more comfortable with them. And then this reduces. So you have square root of 10 over 2. And remember, this isn't in a radical, so I can't reduce it with something that is. So I need to multiply by the square root of 5. So I get 4 square roots. These can come together to give you the square root of 15. Square root of 5 times square root of 5 is 5. Remember, that can't reduce. This isn't reducing, so you're finished. Now here, don't multiply by the square root of 8. It's too much. This is overkill. You're multiplying by too much. Why do I say that? Prime factor this first. It's actually 2 cubed. If the exponent, let me change that, it might be a little hard to read. If the exponent is a multiple of the root, in other words, if I had the square root of 2 to the 4th, then everything would come out. But it's not. So what I'm really missing is 1 more 2, not 8. So your answer is 3 square roots of 2 over the square root of 2 to the 4th, which is 2 squared. If you want to write it 3 square roots of 2 over 4, that's fine also. Okay, heck of a 2. I'm just cautioning you about multiplying by something that isn't prime factored. Here we could get away with it because it was 2 times 5. They were both to the first power. So I needed another 2 and I needed another 5. All right. Here you can reduce. They're both radicals. So I can reduce them. 6 goes into itself once and 18 3 times. So that's 1 over the square root of 3. So we're right back to this problem. So your answer then is square root of 3 over 3. All right. I can't cancel here because this isn't in a radical. Prime factor it. 2 and 12. 2 and 6. 2 and 3. So this is 6 over the square root of 2 cubed times 3 to the first. You don't have to put the 1. I'm doing it to illustrate a point. It's a square root. So I need that to be a 4, this to be a 2. So I need 1 more 2 and 1 more 3. So in other words, square root of 6 is what you're multiplying by. 6 square roots of 6 over, I'm going to slow it down, square root of 2 to the 4th, 3 squared. You're square rooting. 2 goes into 4 twice. 2 goes into 2 once. So that's 4 times 3 is 12. 6 goes into 12 twice. So square root of 6 over 2 is going to be your final answer. All I did was reduce this fraction. Okay? That's just 1 over the square root of 6. I'm not sure why I typed it that way. That's made up of 2 and 3. I need another 2. I need another 3. So I'm going to multiply by the square root of 6. So that's square root of 6 over 6. Square root of 6 squared, which is 6. Okay, cube root. That's 3 to the first. I'd love it if I had the cube root of 3 cubed. So how many more 3's do I need? I need 2 more. 3 squared and 3 squared. So you can, guys, if you want, you can write it as 3 squared or you can write it as 9, whatever your preference is. That's now the cube root of 3 cubed. so the bottom is 3. Make sure you prime factor stuff. So that's 1 over the cube root of 3 squared. I want that to be a 3, so I'm going to multiply by the cube root of 3. So the top is the cube root of 3 over the cube root of 3 cubed, which is 3. It would be a mistake, if you guys left it as 9, to multiply by the cube root of 9 squared. Because there you're multiplying by 81 over 81. That's way too much. I only need one more 3. Okay? Fourth root. If that was the fourth root of 2 to the fourth, everything would be okay. So how many more 2's do I need? Well, I don't know why all my 4's tend to close. I need 3 more 2's. 3 more 2's. So I have 2 fourth roots, there we go, it stayed open, of 2 cubed, or 8, whichever way you want to write it, over, it's now the fourth root of 2 to the fourth, so it's 2. And the 2's cancel. Cube root, mixing these up, so I need a cube root of 2 squared, so that becomes 8 cube roots of 4 over, that's the cube root of 2 cubed, or 2, then this reduces, so I have 4 cube roots of 4. If you guys can reduce, it's always a good thing. 2 cube roots of 2 over the cube root of 9, so that's 2 cube roots of 2 over the cube root of 3 squared, so I need one more 3. So I have 2 cube roots of 6 over, and now that's going to be 3. You're finished. Okay, when you got variables, same deal goes. I would love it to be a multiple of that root. So it's a square root, so I need one more x. So I have the square root of x over x. I need a 3 and an x, because it's a square root. So it's 5 cube roots of 3x. It's now 3 squared x squared, so 3x. I need one more x to get it to be x to the fourth. 3 square roots of x. It's now x to the fourth, a square root of x to the fourth, so it's x squared. This can reduce. I don't know if there's any reason. Well, yeah, I guess how about I always tell you to reduce? How about that? So we got 6 square root of 6 over the square root of xy. I need one more x and y. So I have the square root of 6xy. This is why I hesitated, because the x is just getting put back upstairs again. Usually that doesn't happen, but in this case it did. So now I have x squared, y squared on the bottom, so it becomes xy. It's a cube root. I'd love both of these exponents to be a 3. So I need a 2 squared and an x squared. Oops, cube root. 2 squared x squared. So it becomes the cube root. If you can leave it like that, or you could write it as 4. I really don't have a preference. Then that's going to be 2 cubed x cubed. So 2x is what would pop out. So I'm going to need some things that are in cube roots before I even worry about what they are. I need 2 more 3's. And I need one more x. And I need one more y. So it's y to the 6th. So if you need to, slow it down and write it out. 9xy over a cube root. So that would be 3 cubed x cubed y to the 6th. You don't have to write this step. It's only there to help you if you need it. So it's a cube root of 9xy. Then it's going to be 3xy squared. Okay? No shame in writing that step out, you guys. All right? Thank you much for your time, and I believe that's the end of it. Yep, because this is your homework.